morning everyone. Today we are going to see software testing unit 1 session 3. In the previous topic we have seen cyclomatic complexity and how to draw the control flow graph, and from that control flow graph how to find out the various paths and how many exactly test cases you need to test all those various paths. And to calculate that we have seen two formulas and various examples we have seen. So in today's session we are going to see again some example on cyclomatic complexity, and we are also going to study various code coverage testing tools and how the code coverage testing tools is going to help to find out the statement coverage, branch coverage, condition coverage, and so on. Let us see another example. So they are given here while loop. So these two statements we have considered into a single statement here. Another statement, if condition is another statement, and this is the termination, and statement 6 and 7 termination of the loop. So we have here two loops, loop 1, loop 2, and we have here one conditional statement. So total how many predicate nodes are there here? 3 predicate nodes. So 3 predicate nodes means 3 plus 1. So from here only understand number of predicate nodes is 3. Number of predicate nodes is 3 plus 1, that is 4. So you need here at least 4 different inputs, different test cases to test all the paths. First you convert this into flow graph. See, this is the flow graph. You can see here. If the while loop is through, see, if this while loop is through, it is going to execute second while loop. Then even if this while loop is through, it is going to execute third condition. You can see here. Third we have conditional statement. Then if it is true, it is going to execute fourth part. If it is false, otherwise it is terminate the loop. You can see here. This is the termination of that loop, second loop. And from that it is going to return back to the second loop. Then if the second loop is false, directly it is going to come to the statement 6. Okay, you can see here. If the second loop is false, directly it is going to execute statement 6. Then it is going to go back to then from that it is going to go back to the first loop. You can see here, from that it is going to go back to the first loop. And if the first loop is false, directly it is going to execute statement 7. So these all statements are for true part and this is for false part. This is the first while loop and this is for true part, second while loop, and this is for false part. This is for true part and this is for false part. So like this way you need to convert the code into a control flow graph. So you understood here how many paths are there. So you need here at least 4 test cases. So put that total 9 nodes, 9 edges. You can calculate here edges 1, 2, 3, 4, 5, 6, 7 and 8, and this is 9. So total 9 edges plus minus 7 nodes. So you will get here 4. And when you substitute in that, here also you will get 4. So both are matching here. So 4 test cases are necessary to complete all the paths. So you need to decide now paths, how you are going to test. So you need to decide the inputs now. You can see here different paths are there, 1 to 7. Okay. So what you do, select one input value for this path Select another input value so that it can cover these all paths. Select another input value so that it can cover these all paths. Okay. 1 to 7 means you can see first one 1 to 7. So first, in the first test case, you select the value where your loop condition is going to become false. In the second testing, you consider see 1 to 2, 2 to 6, 6 to 1, 1 to 7. That is 1 to 2, then 1 to 6 directly, that here. So when the first loop is through, it is going to test second loop, and when the second loop is false, it is going to come to the and then return back to the statement 1 and then statement 7. So for each independent paths, you take different values so that you can cover all the possible paths of testing. Another example is given here. So you can try this by your own. First control this code into the control flow graph and then substitute into the cyclomatic complexity formula, both formulas, and find out the various paths you can see here in this. Now next we'll see tools for cyclomatic complexity. So to calculate this complexity of a code, there are various tools available. You can use these tools. Okay, static code analyzer for C and related languages. So these are based on different languages. So Dev matrix for analyzing for C# projects, and this is for .NET, and this is Java related applications. So there are different tools for different programming languages. So you can select which is suitable for your code. Uses of cyclomatic complexity. So what is the uses of this? Helps developers and testers to determine independent path executions. Then developers can assure that all paths have been tested at least once, and then helps us to focus more on the uncovered paths and improve code coverage. So from the cyclomatic complexity, it helps the developers and testers, and we can understand total how many paths you have tested by selecting different inputs, and how many you have not tested, that also will understand. So overall it will improve code coverage testing. So now if the complexity, the answer which you get by substituting the value in the formula, if the answer is between 1 to 10, then it means it is a well written code, testability is high, and cost or effort to maintain is low. And if the code complexity is between 10 to 20 values, then it is a moderately complex, testability is medium, and it is cost or effort is also medium. If the code complexity is between 20 to 40, then it is a very complex task to understand. Testability is also going to be low, and maintenance also going to be, you need to maintain it a lot. And if the complexity is greater than 40, then most of the parts it is not testable, and it is also difficult to maintain, and or you can say you cannot maintain it properly. So now these are code coverage tools. So we already seen different code coverages: statement coverage, branch coverage, conditional coverage, function coverage. So based on these coverages, there are different tools available here. You can see here EMA, Cobertura, code cover, ncover, open cover, and coverage meter. Now let us understand how these code coverage tools will be helpful to find out the total number of statements covered, total number of branches covered, functions, etc. So let us understand with help of a coder. So this is the file name iterative.java, and this is the code which will find out the factorial of a given number, and this is the class. These are the packages which are used, and this is void statement, and this is the creation of the object, and here you are displaying the number to accept. Here you are going to accept the input, and then you are going to check here to find out, see whether the entered number is positive or no. Okay, and then if the entered number is positive, then it is going to calculate the factorial of a number and then it is going to display. Now, how you execute this? It will show the output, enter any positive number, and then you enter some input value and it will show the factorial of a number. So, for this input value 5, total how many lines it have tested from this code? You need to find that. So, the input which is supplied is 5. So, for that particular input, total how many lines you have tested from this code? Okay. So, it can be either statement or it can be either how many conditional statements you have covered or how many functions or the methods you have covered from that input value 5. So, let us understand with the help of one tool. So, code coverage testing for iterative.java. So, this is one tool which I am using. The tool which I am using is Eclipse. Okay, under the Eclipse we are testing this code coverage. So, you can see this is the interface of that Eclipse tool. Now, this is the file which we are testing, iterative.java. Okay, you can see here iterative.java. And see, we have covered total 91% of the statement coverage. Okay, covered lines, that is nothing but statement. So, total how many statements were there? Total statements are here 12. So, out of 12 you have tested 11. And the missed statement is 1. So, 1 you have missed. So, from that for particular input, how much percentage of statement you have tested and how many lines, this all you will understand from this tool here. Next, function coverage, that is we also call it as method coverage. So for this iterative.java, there are actually 2 methods. Out of that, one method is tested and one method is not tested. So percentage of function coverage is 50%. Next, branch coverage, that is conditional statement. So let us take here example, recursive.java. This is also the factorial of a number. So total branches, there are total paths, there are 4 paths. Out of 4 paths, you have tested 4 paths. So branch coverage testing is 100% here. So this is how the tools will help you all to find out this all. Now there is another way to design the test cases using the tools. Now this is the code they have given here. Now you need to write the test cases for this. You are going to test this code with various inputs. So if you use the tool, using the tools, you are going to write the test cases in this way. So JUnit, that means you are going to use here the tool JUnit, and in that you have written the test case. So these are the packages which you will insert by default, and the notation which you use here is add test. So you need to understand that this is one test case you are writing. Okay, this is the compulsory. If you are writing the test case, you need to write this. Okay, here you have created the object of that class, and now these are the test cases. So you have written here 2 test cases. This is the first test case and this is the second test case. So for this particular code, you have taken the input 76. Okay, and you are comparing this input value with the C grade. So whether the 76 comes in the C grade or no, that you are comparing. If the result is true, it is going to return the result true, otherwise it is going to return false. Similarly, you are testing here another input value 66. Now 66 also you are going to testing it under C grade. If the result is true, it is going to return true result, otherwise it is going to return false result. So taking various inputs, you are testing here this code. So like this way, for each grade you can take as many values as here. So you can write here as many values you want here. So this is only for grade C. You can also include here the test cases for grade A, for grade B. You can also include here negative values like -76 and check out how this code acts for negative values. You can also take here 0 value and check out how it acts. So this is how you write the test case using the tools. There are also different tools available. So this is one interface for another tool. Here you can see the files and you can see the statements here and so on. You can also see here total how many statements. So total there are 61 and you have tested only 46. And branches, there are 20 branches and you have tested 10 branches. So it is 50%. So total functions are 9 and you have tested only 5 functions. So this is how the tools will help you to find out the code coverage testing tool. And this is another interface. From this interface you will understand that these red lines, it shows that. So these are the lines which are not tested, missed lines. The input which was selected, from that input, it has not tested these lines. So it is showing in red line. And yellow line, it is a partially executed lines. Means half part it has executed, half part not. And this is which has executed these lines. You can also see here also it is showing all. So this interface indicates that all statements have been tested at least once, or all coding has been tested at least once. All the functions, branches, lines, statements. This is another interface. From this interface, the green line indicates that you have tested it. So green line means you have tested it, means you have selected one particular input. From that input, you have tested these lines. And red line indicates that these lines have not been tested from that input. And yellow line indicates that it is executed partially. Half part it is executed, half part it is not executed. It shows. This is another interface. You can see here statements, total and executed, and it is showing the percentage of code coverage testing. And these are the various files. So which tool it is? JS coverage tool it is. Next, advantages of white box testing. So forces test developer to reason carefully about implementation. As developer has to focus on this white box testing, and a lot of errors can be find out here, can be minimized. As the knowledge of internal coding structure is prerequisite, it becomes very easy to find out which type of input or data can help in testing in the application effectively. Okay, as the knowledge of internal coding structure is if you want to conduct white box testing, you should have the internal coding knowledge, which becomes easy for you all to find out exactly where you have made the errors and where you need to change it. It helps in removing the extra lines of code which can bring in hidden defects. Okay, so you can find out which lines are extra, which line to be removed, and where the defect can be hidden there and how you can remove it. It helps in optimizing the code. So these are the advantages. So disadvantages are like developers not finding time for testing. As the developers don't like to find more faults in his own work, so he will try to neglect that part, and he may apply only the few testing. He may not apply all types of testing, and also he may not have the full time. He may not able to concentrate more on the testing because he'll be busy in implementing the code and all. They find blind spots for their own defects, as I told you. And other kinds of errors that white box testing won't find is time and concurrency works, volume and load limitations, efficiency problems, and usability problems. So this type of errors they may not able to find out: time and concurrency, volume and load, efficiency problem, or usability. So only the testers can more focus on these types of testing and not the developer. So here we have seen various tools interfaces and how to write the test cases for a particular code using a particular tool. And in the next session, we'll see some new topic. Thank you.